New Zealand Tech Podcast, the voice of the tech community, proudly supported by Umbrella Connect.
Greetings and welcome along to the New Zealand Tech Podcast. Today we're going to delve a little bit into Emirates Team New Zealand and the role that technology and innovation plays in their work as they move to the cusp of the beginning of racing for the 36th America's Cup. I think this is pretty exciting because if we look back over the years, Emirates Team New Zealand has done incredibly well. And I think there's a key role that technology and innovation play here. So, real privilege to welcome first up Tim Meldrum, designer at Emirates Team New Zealand. Thanks for coming along, Tim.
Thanks for having me.
And also we have Ollie Hill from HP, GM in the GM role now.
Yes, country manager.
Sorry?
Close enough.
Okay, I get these titles wrong. My apologies.
No, good to be here. Thanks, Paul.
Yeah, great. Well, let's delve in. I'm keen to get a little bit of background to start with. Tim, what's your background? And you've ended up in a pretty exciting and important role. I think a lot of Kiwis are watching on to see how Emirates Team New Zealand does, and ultimately the design work behind the scenes is pretty critical to the outcome. So, how did you get here? What was your first sort of involvement in the world of sailing and so on?
I've always been fascinated with how things work. So I grew up with a pretty handy father in a workshop. So had my hand around welding and making trolleys to race in the local derby from a young age. And then also grew up sailing up at Sandspit Yacht Club, racing out at Algies Bay. And it was a pretty humble affair up there, but I got a taste for the sea and boats. So I guess combining that, my passion for how things work and quite a mechanical mind, naturally led me down the engineering path with a sort of swing towards the marine side of things. So first job was as a draftsman in composite engineering company, and that evolved into more of a composite engineering role, and then got into the yacht mast area with Southern Spars, and just found the draw of all the shiny bits a bit too much, so swung over into more of the mechanical design. And yeah, that was sort of my foot into engineering world, I guess, and along the way I studied mechanical engineering. Cool.
And so how did the door open into Team New Zealand for you?
Yeah, that was a childhood dream, and it was a long, sort of hard-fought battle to get in there, I guess. I always wanted to do it, and it took me 20 years. So, I worked in the real world, normal industries, albeit marine ones, and just tried to, do a good job of what I did there, and, got to know people within the industry. And one day I had a phone call from a ex-colleague who worked for the team and thought I should come along for an interview, so that was my big opportunity. And
what did that feel like? Was it quite a bit of pressure, like having to go to that interview, or you'd already been told by your mate, like, look, you're in and it's all good?
Yes and no. I mean, I probably overdressed. It was a bit more casual, I think, when I actually got there.
Yeah.
And I think it's a pretty down-to-earth team. That's one thing. A big thing about the team is the culture. It's all quite a level culture where everyone respects each other. It's quite flat structure, and it was good there. Just a bit of a chat and talk about yourself, and it's pretty important that you got the right attitude and temperament to fit in, as well as obviously the skills.
Yeah. Cool. Oh, that's awesome. We'll look forward to delving into the role a little bit more. And Oliver, or Ollie, which do you prefer? I usually call you Ollie. Is that all right?
Ollie's good. Yeah,
that's all right.
I prefer Ollie.
Yeah. Great to finally have you on a podcast. I mean, I can't remember how many years ago that we first met. You've been working with HP for how many years?
Well, it's coming up 17 years, which obviously I started when I was about 12. So no, it's been a long time, and sort of HP sort of similar to Team New Zealand in terms of cultures. and that we're innovating all the time. People say, 17 years, isn't that boring? I was like, if I look back 17 years, we're a completely different company than we are today, which keeps a lot of our team, because there's a lot of people that have been around a long time. Same thing, it's always refreshed, always something new. So
yeah, I think, look, there's something to be said for having team members that have got a history with the business, and some businesses, things seem to sort of flip over on such a regular basis. No one really has too much of the background, and I guess relationships sort of can fall by the wayside. So it's probably a good thing in many ways.
Well, it's high trust levels, right? Yeah. You know each other for a long time, so you can do more innovative things with a higher level of trust. So it works for us.
Yeah, cool. Well, and as well as being a supporter of New Zealand Tech Podcast, there's obviously a close relationship there with Emirates Team New Zealand. I'm always sort of curious how these things come about, because especially one like this where it's not just sort of a logo slapped on a boat or a sail. Was it a big deal trying to get this thing across the line and make it work as a partnership?
Yeah, it's evolved, right? So this time we're a sponsor. Previously we were a supplier, and the way it sort of came about was my predecessor literally had a relationship with Dolts and got a phone call saying, we need help, and we came along and helped. And at that stage it was compute requirement, and so we worked together with that, and we were just really proud to feel like we were actually making a difference with the team. It's not, like you said, putting a logo on something. It's actually helping the team in what they do and helping them innovate using our expertise and our amazing team to help their amazing team. And then when the opportunity of defending the cup, and we saw the opportunity with the rest of our portfolio, including digital manufacturing or 3D print, we were like, well, this just makes sense for us to get on board in a better way.
Cool. Well, I'm definitely keen to to hear a little bit more about that as we delve in. But first of all, I'm curious about the role that technology and innovation has really played over the years for Team New Zealand. And Tim, while you haven't been there for the entire history, it sounds like you've watched pretty closely and have a good knowledge. What's your sort of take on how things have evolved over the years since New Zealand's first America's Cup campaign, in terms of the technologies? I guess the boats themselves look very different. There's a lot of things from an outsider visual perspective, but there must be a lot that sort of happened behind the scenes from a design and tech perspective too. Yeah,
for sure. I mean, I think to respect the past a bit here, if we had the technology 20 years ago, we would have used it, and it's no less effort put in today than what there was with the more limited tools of the past. But I think mainly it's two things. It's the tools we have available, and then it's what the boats have become. So, you wind the clock back and look at Black Magic and when we won then, and there's probably some computing software around for hull shapes, but it's still in the era where there was a senior naval architect that penned a design, and it was a bit of dead reckoning and beautiful curves and things like that. And then you look at where we are today with, we've got this room of HP cluster computers that run all our CFD simulations. So, to touch on what Ollie was just saying there, what's
CFD, by the way?
Computational fluid dynamics. So, doing what you do in a wind tunnel or a tow tank, the rule this time prohibits you from doing that physically, so you have to simulate it, and that actually was done to save cost, not necessarily to promote technology, but the technology is actually a lot better anyway. If we had the choice, we wouldn't do a tow tank test. It's having the partnership to have that kind of computing horsepower just sitting in a little air conditioned room downstairs is pretty neat. It's not like we just had a whole lot of computers turn up in a box. It takes a bit of effort to configure that and get it working.
Yeah. So that role, of technology. Yeah. I mean, I guess if we look back 20 years ago, what was available to us was nothing compared to what we have today. And sometimes I look back at where was technology when I left school, and I look at it and it's like, wow, it's thousands of times more powerful, and we've got access to such incredible computing resources. So your virtual sort of wind tunnel, as I would put it, or that virtual environment. I can imagine that just wouldn't have been possible, by any stretch, sort of 20 years ago, to be able to do what you can do today.
No, not at all. And the bits under the water are so important. They're the parts slowing your boat down the most if you get them wrong. There's a whole lot of trade-offs, of course, underwater, but we pay a lot of attention to our hydrodynamic shapes. I guess going back a second too, with technology here, when we were the defenders and had to write the rule, we needed to come up with a class of boat, and we were collaborating with Luna Rossa on what boat to do, and we really wanted to get it right, but yet we were pioneering a new class, a complicated class that had a lot of skeptics, and so we had to iterate through a whole lot of crazy ideas that people were putting on the table and emerge with the victor of a new class that was going to be a good boat that everyone enjoyed and wanted to use again. And so we've actually got a simulator that is not just used for creating a rule, it's used as a training tool as well today, but that was crucial in the development of the class rule, was to throw some variants of all our crazy ideas on this new boat, and we proved to ourselves that this was actually a good boat, and we backed ourselves that it would work. And I think if you listen to some of the other teams, there's quite a few people full of praise that it's actually a pretty decent class, that all the parameters and mast height, boat weight seems to deliver a good racing boat. Yeah,
because you effectively had to invent something that was new, right? You was just going, we're going to do something different for this series of races.
Yep.
And everyone's putting many millions of dollars into competing, so if you stuff that up, that's a pretty expensive mistake. So did the technology give you a really high level of confidence in terms of that this was going to play out well, and have that right sort of balance of speed and agility, and I guess safety's a factor too, right? Because you got a bunch of folks that are on this boat going very, very fast.
No, it did, and we believed in our tools. We'd developed them for Bermuda, and then we had to adapt them quite a bit to suit the monohull, but fundamentally the same engine behind the simulator was evolved to suit the AC75. And in terms of safety, just to touch on that, these boats actually have proven to be safer than the catamarans. Guys are locked in the trenches, they're a lot less likely to fall over the side, and the whole crew isn't running from one side to the other. So I think all in all it's come out pretty well.
Yeah, that's cool. And looking at the software that's behind it, you mentioned that had been used in the past. What's the story of that software? What's its history? Are you able to use a whole lot of off-the-shelf stuff? Is it all sort of custom coded, or does it sort of sit somewhere in between in terms of the bits and pieces you use? And of course, we want you to spill all your secrets that none of the other teams know. No, of course not. Yeah. But what can you share?
I actually couldn't tell you how many different pieces of software we run in the team, because it's quite a lot. And within each department, there's specialists. We'll have one guy that designs printed circuit boards, and I couldn't tell you what his software is for that. But so there's a whole lot of little niche softwares that we need to have. The engine behind the simulator is called Gombok, and that's my boss Dan Bernasconi's baby, and so that's a ground up piece of software he's developed, and that's quite unique in that it, while it looks like a PlayStation game when you're in the simulator, it's actually a live physics platform. So we can throw into the simulator one of our appendages, foil shapes, and put in the mechanical properties of it, and we can throw the boat through tacks and jibes, and we can actually learn the way the foils deform under various different load cases. So it's a pretty advanced tool that, gives us a lot of confidence. And all of these things, when you're writing them from the ground up, are quite, you have to start somewhere and get it going. So it was a lot more basic in its first versions, and it's just a always evolving bit of kit really that just gets better and better. And the more once you actually build your first boat, you've got a lot of data coming off the boat, so you pump that back into the software. A lot of it's based on some factors for rates of movement and things like that. So the more you use it, the better it gets.
Yeah, that's really cool. So I would see that as something that really puts Emirates Team New Zealand in quite a good position. As every time America's Cup comes around again, you've built on those previous things, and I guess in between times you have to keep developing it. How do you think that compares to any of the other teams in terms of, do you know much around how they operate? Because I guess, say on the US side, we don't have, say, Oracle involved, haven't had them involved this year, so it's like there's a whole new team again. So are they maybe potentially starting a bit further back, and that we get that benefit of the longevity of Team New Zealand?
Oh, for sure. That longevity is one of the huge strengths of the team. But to answer your question, I don't think you can really have a serious chance without a form of tool like this. The other teams all had them, we understand, and you look at American Magic, they had a collaboration with Airbus, so there's usually some big kind of software deal going on behind the scenes with all of these teams.
Yeah. Oh, that's really interesting. And so you've talked about the sort of simulations. I'm interested in where the 3D printing part sort of comes into that. So obviously there's a huge amount that you can do in software, but it seems like there's a bunch going on with the 3D printing tech. And 3D printing is sort of, I guess, one of those things that we've talked about over many years, and most of us don't see too much that sort of goes on in terms of 3D printing. We know it gets used in sort of certain places, so kind of curious to delve into how you actually utilising the 3D printing tech. And I know, Ollie, I was at an event in Silicon Valley some years ago. It was with one of the automakers, actually, with Ford. We were actually the location we were at was right across the road from Tesla HQ, actually. But one of the things they were sort of really talking about, a whole lot of new technologies coming through, and one of the things that was being unveiled was what was happening with HP on this new 3D printers. Now, the technology has been with us a little while, but it's not something that most of us would actually see day to day, because these aren't little home 3D printers or things that you see at the warehouse stationery. This is pretty industrial level gear, right?
Yeah, absolutely. And that is probably one of the things with 3D printers. It's such a broad topic. When people see it, they think of what they see in a retail store or maybe at their friend's house. And yes, that is 3D printing, and it's an important part of it, but this is something completely different. And I think you can be limited in your imagination by what you've seen, and might think that that's the limit of the possibilities of the technology. I think what we've shown here is this is obviously at a different quality and finished part production quality, rather than sort of prototyping sort of toys. I think one of the important aspects of this partnership has been the fact that we've put the machine actually in the base, and that's what the sort of partnership has enabled us to do. So that sort of really changes the usage of it as well. As when you're having to outsource the product, you can sort of take advantage of it in one way. When you actually have it on site, and you can literally hit print, wake up the next morning, and the part's finished, no shipping time, you start to get that innovation speed. you can sort of iterate more times. It's sort of 3 times faster because of just how quickly you can print off the parts as well. So
Yeah.
but back to your question as well, the sort of automotive industry is huge. We've got partnerships with Ford and BMW and Volkswagen where they're literally making parts for cars. Now, a lot of people just wouldn't even realise that the cars that are coming off the production line today actually have 3D printed parts in them, because it's just how they produce it now. For them, it's not even news anymore. But for businesses to understand how they can apply it, it's sort of, you need to go on that education piece to show them what is possible.
Yeah, look, I think looking at that auto space, which is a little bit off our discussion today, but I can see a tie back. I remember chatting through with Ford around how long it would take them to come up with a new car model, and why they were releasing technology one day that already felt like it was out of date, right? And I think we've seen that whole industry under a lot of pressure because of what's been going on in Silicon Valley, and varying companies like Tesla that have really sort of been upping that pace. And I imagine there's sort of a crossover here with what you guys do, Tim, is that you've got to work at this incredible pace, because you don't have 10 years to design a boat or 5 years to design a boat. It all has to happen pretty quickly. And then what we've seen over the last few months is that there are actually changes going on after the boats have even hit the water. So how does all that sort of how does that fit together? How does this iteration work, and where does the 3D printing fit into the mix?
Yeah, well, you're right about the speed. We have to move really quick. It's the nature of the game, and sometimes you've designed something and it's got built, and then the sailors have moved on and they've already got a better idea, and it doesn't even get used. So you're kind of always sprinting in a design sense. That's part of the fun of it. It's quite an unregulated world we operate in, so we're not burdened like the aircraft industry with a whole lot of checks and regulations, and that something might take 2 years to actually get on an aircraft at best.
And then some of them still stuff it up.
Yeah. So going back to the printing technology, Ollie touched on a kids printer. This is the core of what we're finding with the benefit of the machine we have. We've gone from the printer we had the last 2 cups in Bermuda and San Francisco was I call them a spaghetti printer. The SLA printers that have a spool of plastic that squirt out a part. And the problem, they're great printers and they're very affordable, and you'll have a lot of them in schools and homes and things, and you can make some neat shapes, but they fundamentally are like a layered component that has a grain effectively. And so we found in our application most of the parts with that technology was quite non-structural, little convenient enclosures and brackets and things, but it certainly had quite a physical limit to it. The other unique problem we have is waterproofing. So we'd spend hours lacquering these things with 3 coats if we're making an electronics enclosure. We're always on this weight-saving mission, so we're often taking a standard part and ripping the back off it that's heavy and trying to make a smaller, lighter enclosure.
Oh, that's interesting. So what would those parts have been to start with?
Well, we do a lot of our own sort of custom printed circuit boards now, partly because we have this machine and we have the confidence to just do it from scratch. But we had like one of the displays that we needed to run with a screen. It had quite a heavy metal back on it. We just printed up a plastic back for that.
Done. Replace it.
Yeah,
that's pretty cool.
But this HP machine, what it gives us is a part that's got no grain structure. It's a sort of a homogeneous, uniform plastic that's got good nylon properties, like a sort of rotary molded or injected part. So it's really created a new category of component that didn't really exist before. And I think what I do is mechanical system design, and most of my work's drawing parts and most of my assemblies have a lot of loaded structural parts in them, titanium, aluminium, metals that usually don't corrode. But more and more we're seeing parts of those assemblies be printed, and that's just because there's often semi-structural or non-structural components that are just really well suited to that technology. So it's filling a really valuable niche, and it's saving us having to go to a machine shop. It's a faster, cheaper way to make a part that's often lighter and better.
Yeah, that's cool. And what's been the role of 3D printing in terms of helping you iterate and improve on existing designs and testing and so on? How's that played out for you?
A few different ways. We often will just make something that is a equivalent shape of perhaps an expensive titanium metallic part. You just might want to do a fit check, and so spend $100 on the raw material of the plastic for a $5,000 part, make sure it fits. So there's a bit of mocking up, sort of dummy fitting that can go on. We actually make some small scale tooling, so we'll use it to laminate a carbon fibre part out of, because we know that we can have it done overnight. That's it really.
I guess with that, that tight limitation on time, you've only got a sort of certain window. Anything that can, help you speed that up has to, end up giving you a better boat and a better result at the end of it. And we tend to also have that the challenge of we don't necessarily have our team funded by somebody that's worth $50 billion and just happy to keep doshing out the dollars. How helpful is 3D printing from that perspective? I mean, you just talked about a $5,000 part. You can make sure you don't order the wrong one. Does it end up making much of a difference, do you think, in the scheme of things financially, or is it more the speed is the big benefit?
I think it does. I mean, I think also we've got this wonderful partnership with HP, and this machine just turned up one day, probably with a lot of haggling in the background I didn't know about. But it's probably fair to say if we didn't have it there and hadn't actually had the opportunity to learn what it does, we might not have gone hunting for it, because it is a lot more expensive than your home handyman machine. But once you've got it there and you've started utilising it, I mean, if we ran out of materials one day, and boy did it get missed when we had a bit of downtime. You don't realise how much you need it until it's gone. And I mean, we really hammer it at the moment. It's we're probably doing 3 to 4 print runs a week on the machine. So and it's neat. You can, the email will go around, get your prints to me by midday, and so you drop all your files in the folder, and one of our guys nests it all, and the next morning you've got your parts in hand, and that's a pretty impressive turnaround.
I think that's one of the interesting things about having it down at the base, is sort of because we use it as well, because we're so close to the team. But we've been really learning from each other. So they're pushing the boundaries on what it can do in terms of the waterproof qualities, and also in terms of and that's under pressure waterproof qualities. We hadn't even thought to test the product for that, because we hadn't ever had a use for it. So the team's coming back to us going, did you know it's so up to this many PSI and whatever, and we're like, or this many bar, and we're going, no, but we'll feed that back to the mothership and they'll be interested.
That was the first thing I actually printed, was like a rip-off hose fitting that you could just plug into the end of a hose that just was sealed off, just to see if it leaked. And it's so important for us to keep everything dry.
Yeah. Oh, that's pretty good. And what's the sort of response from? Because where's this technology developed out of, Ollie?
Yeah, well, actually, the funny thing is with our 3D printing is it actually comes from our printing business. Our inkjet printing business. Essentially, we've taken the technology of being able to place very small bits of liquid in a very precise location, which is inkjet printing and applied that to 3D print, which is, we use fusing and finishing agents on a powder bed to apply the same level of accuracy. So that essentially is done in the US and is constructed in Singapore. So we are very close to our Singapore hub. And we've even actually, one of the things in terms of where that machine was, because it's in a very public space at the base, and the airflow was coming out towards people that were walking past, and straight away they were like, this isn't really working because there's this hot air blowing out. And so we together designed a new part for the printer, which
cool.
actually was like an exhaust, printed on the printer for the printer. And then we said, hey, here's a design. If someone's got the same problem with it, they're going to have people walking past this, you can have an exhaust sent there back, and they're like, oh, we'll look to incorporate that in future iterations. So genuinely, two teams really working together on something that is very much leading edge.
Yeah, did you put on there that if they end up adding that into future machines, it's got to have a bit on it, designed in New Zealand, and bit of credit back to Kiwi ingenuity,
I like that. I'll actually contact the team after this.
Oh, that's really cool. So you said an interesting thing there, Tim, that if it hadn't have been for the printer having sort of turned up, you might not have necessarily gone out looking for it because you didn't actually know exactly what it might be able to add.
Yeah, that's right. And what it is it's a lot closer to replacing a machine shop in a way. It's delivering us parts back that are, like I mentioned, semi-structural. So we do...
Because your machine shop makes things out of, metals, right?
Yeah. So we now do like a lot of the chafe guards and parts on the boat that actually take quite a beating. They might not have 10 tons running through them, but they might be in a position where they get a lot of wax, from stray ropes. So if we were to print these things in fluorescent pink, because the printer can, but we don't, and you could actually look at the boat, it'd be really lit up with the quantity of parts all over the boat, but sadly we make them all matte black so no one can figure out what we're up to.
That's cool. So with that in mind, I'm curious about sort of looking forward, how do we see these sort of new technologies actually, I guess, outside of Team New Zealand, but looking at New Zealand as a whole, as a country, we want to be leveraging the latest and greatest of technologies. But we sometimes have that challenge, and I think it's kind of a constant challenge, really, particularly with how many smaller businesses we've got, where it's really hard to keep up with the play on all the latest technologies. And then there are technologies that might be, in plain sight to some degree, as what you've just described. We're seeing all this 3D printing on the boat, although we can't necessarily distinguish it. There's always new things coming through, and I think Team New Zealand has always been an example, to a degree of an extreme level of innovation that happens on our shores. But as a country, I think it's really important that we need to sort of follow Team New Zealand's lead, as it were, in terms of how we do business and how we leverage technology. Any thoughts on kind of how we change that? And I'm not saying we do really badly, because we've got a lot of great things come out of New Zealand, and Peter Beck's announcement with the latest from Rocket Lab, it's pretty exciting, and is in a sort of similar class where there's just an extreme focus on utilising the best of technology and innovating. So there's some comparison there, but we need this sort of thing just to be the norm, right, in New Zealand, if we're going to keep moving forward on a global stage.
Absolutely. They actually use a lot of 3D print.
Okay, there you go. That's true.
Yeah, they do. So I think there's two things. One's education, and I'll touch on that, and the other is one of the things that holds us back is our scale. So a large US corporation will just go, I'll just grab one of those and try it out, whereas most New Zealand businesses just can't. They don't have the scale to make an investment like that, just on the off chance that it might work. And to Tim's point is going, well, they wouldn't have known how good it was if they didn't have it. There's lots of people that don't have it, therefore don't know how good it is. So I think we need to get some scale and some cohesion between different organisations and bodies to say, hey, we're going to invest in this type of technology and give more people access to try it and make it easier. So I think that's a really key one in terms of how the country can invest in not just 3D print, but other technologies that can be shared and tested and sort of piloted. And then the other one, massive one, is education system. The education system is always just a little bit, to keep up with that bleeding edge, and you really need people coming out of school and university going, I've got this under control. We took some high school students. It was actually their very last day of school last year, and they were going off to do engineering at the University of Auckland. And when we took them through what was happening at the Emirates base, they were just like, I can't believe it. I've seen 3D print, and it was this product that I couldn't do anything with. And you could see their eyes sort of widen. And I just imagine them going through university having this, but what can be next? What could I make? How could I make this better? And obviously it's a small group, but you think if we could propel that and make that broader and give more people that exposure to it, then we can as a country do a lot better.
Tim, your journey, obviously the technology you've used throughout your career, must have kept changing. Is there anything sort of unique in the Team New Zealand environment that you've noticed, other than the fact that, well, I guess this is probably part of it, that the whole country feels a vested interest in Emirates Team New Zealand's success, right? We all want that outcome. So that sort of 2 degrees of separation. If somebody has an idea or has some technology or something that may help, and they've got the right connections in place, then maybe you'll hear about it. But I guess you could end up with too many inputs there at times. How does it look for you and those on the team to keep up with the play on technologies?
Yeah, we have to be eyes wide open and willing to take it on. We have to be a bit cautious. We don't want to rush into something necessarily that suddenly puts something at risk. So we do adapt to technology, but we try and do it for the right reasons. But I think we're always looking. We are a team where the hierarchy is such that you can put your hand up and have your say. And we've got quite a vast skill set of people that are in the team. It's not all about, you've got to be an ex-sailor to be on the team. So we've got people coming from motor racing industries, from dairy factories in the Waikato that are good at control systems. Like you name it, it's a lot of down-to-earth people that bring in experience with different technologies that really make us a rounded package.
Yeah, cool. And if we were to step back a little bit, do you think that there's going to be still a fair bit of change ahead, or are things sort of starting to plateau a bit in terms of some of the technologies that we kind of so I look at some technology areas and you see these sort of great periods of sort of growth and change, but in terms of the sorts of things you use, is it now more gradual change that you would expect to see over the years ahead, or have you got ideas or things you've heard of that are coming that could be big game changers again? Yeah,
I think it's always going to keep coming in waves. If we take the 3D printing one as an example, I do a lot of mechanical machine parts as a mechanical engineer, so to be a good designer, you really need to know the machine that you're designing for, or the manufacturing method. So I've always prided myself when I draw a machine part, I don't get the phone call from a machinist saying, how the hell am I going to make this? This is impossible, I can't get my cutters in there, or it's so complex, I'm going to be here for days. So I'm always trying to find this right balance of process, time, money, people to get a good part out there. It's got to be made quickly at the right price, and so then you go and throw 3D printing in the mix and you just chuck all of that learning out the window. And so I've had to go through a real journey of re-educating myself about designing for a new type of manufacturer, the printer. And this printer loves complexity in terms of curvature. It loves internal cavities, which you could never get a cutting head into. It doesn't like really thick concentrations of mass. So you really got to understand the process, and that's been part of the journey for all of us using it, is to learn the nuances of this machine. So I'm on that learning curve right now. There's a lot I still need to learn. We're not just printing in plastic. We do use some of the local manufacturers in the laser sintering and electron beam for titanium and stainless steels. So there's a few parts like that on the boat. So it's always learning.
Yeah. So what machines do they come out of? The titanium parts and so on.
There's two primary methods that we use, and two good. Well, it's probably more suppliers in New Zealand. So one of them's a laser sintering technology, and the other one, I said, is electron beam. So they've both got their sort of strengths, and depending on the part, we probably pick one for one, one or the other, depending on what we're up to.
Yeah, hence that getting that knowledge and knowing which to use for which purpose.
Yeah, exactly.
That's great. Was there anything else that we haven't covered that we should delve into before my last question?
Depends what your last question is. No.
Well, my last question was how are our chances of winning the 36 America's Cup, and is the technology going to help us bring it home on the day?
Well, I think our job's been, as a design team, to put the fastest boat underneath the sailors and then let them go out and try and win races and win the starts. So we've tried really hard with all the technology available and a lot of hard work to create a fast boat. It's hard to, without having a lineup, to say right now whether it's the fastest or not. We certainly think it's competitive. It's a bit more unknown how well we're going to do on the starts, but we're trying pretty hard against our chase boat at the moment. So I think we're going to go and give it a good bash. Yeah,
the boat's certainly looking pretty snappy out on the water, and I guess in the races that we saw late last year. So very hopeful for some good results.
I'm hopeful.
Yeah.
Nervous.
Try not to jinx it.
I think the history will say let's not count our chickens. So we're
I was in San Francisco and saw some of the races. So these things can have unexpected elements to them. So I wish you all the best.
Very good, thank you.
All right, thanks very much, guys.
Yep, thanks for having us.
Much appreciated. All right.
Yeah, thanks for your time.
Cheers.
New Zealand Tech Podcast, the voice of the tech community, proudly supported by Umbrella Connect.